Mr. PM Nanda is Senior Vice President, Greenco Group. He has more than 33 years of experience in the energy sector, including specialized hydropower experience for 28 years and more than 5 years in the hybrid renewable energy sector. He's currently working on pumped storage projects and two renewable integrated projects with storage. He has worked on more than 20 hydro projects and an equal number of solar and wind projects from concept to commissioning across 15 states in the country. He also has experience in complete project management, including planning, execution, techno-commercial issues, environmental and social issues of hydro and renewable power projects. He has worked with both the government and private sectors. Mr. Robert Oesterreich is Vice President, Global Hydrogen Sales at Chart Industries. He has over 23 years of experience in industrial gas applications and business development across a variety of industries, including hydrogen energy, steel making, aluminium, and solar photovoltaics. He's currently responsible for executing global hydrogen equipment sales strategy in the hydrogen energy markets. His responsibilities also include developing key partnerships, identifying strategic investments, and creating new product offerings. Prior to joining Chart Industries, he spent 10 years developing the US hydrogen energy business for a major industrial gas company. This included developing new hydrogen supply chains and building and operating hydrogen fueling stations for forklifts and light-duty vehicles. He's a chemical engineer. I welcome both our speakers. So the format of the session is going to be that we'll have a question and answer round with me and my co-panelists, and then we move on to the audience for their questions. So I'll start with you, Mr. Nanda. That what are your thoughts on the green hydrogen potential in India, the various market opportunities? What is the rationale behind adoption of green hydrogen in the country? And if you could, and what is your company's plans and recent developments in that regard? So if you could spend 5 to 7 minutes, and then we move on to you, Mr. Robert. So you're muted. You'll have to unmute yourself. Yeah.
Yeah. Thanks, Khushbu. Yeah. As far as this green hydrogen potential is concerned, or the future prospect is concerned, in India, I think it has an enormous potential in India. And the only thing which is worrisome at this stage is that the atmosphere or the background at this stage is not very encouraging for the private players or industry to jump into that. We in Greenco being almost the largest player in renewable sector, we are strongly thinking and trying to venture into this field shortly. So the plans are still in the formulation stage because the policy background is not that encouraging as of now, which is available at this stage. And there are other aspects associated with the commercial viability of the hydrogen or the business model, which are we planning to come up with. And there's another aspect regarding the codal standards, safety aspects, and other issues on which India is lagging a lot at this stage. So this is a scenario where, in spite of our inquisitiveness and our endeavor to venture into the industry, we are feeling roadblocks at this stage. As far as our plan is concerned, we definitely will going to venture into hydrogen shortly. We'll be there in the play. And the main aspects we are looking into is the storage and the big transport sector, FCVs. So that's the area where we are formulating plans, and we'll be trying to venture into that. But the issues associated with the R&D or the technology availability at this stage and the commercialability of that technology are the issues where I think a lot of things are going on all across the world and are happening at very fast pace. So India has to jump in a big way in the electrolyzer market, because unless until we have that domestic market available in the electrolyzer case, I think the commercial viability of hydrogen will be a far thought for us. So that's the area where I think, because we are talking about a scenario 2030, we are not talking about 2022 or 23 in case of hydrogen. we are just talking about the pilot projects for coming 4-5 years, then we want to have that commercial viability somewhere around 2030 we are talking about. So the electrolyzer market is one thing where if we start spade work at this stage itself, I think by the time we are full pronged into the hydrogen market, I think we'll have a lot of business models available by that time. And second thing, as our government is quite keen on hydrogen, green hydrogen scenario in India, and we are expecting shortly, maybe another 2-3 months, we are expecting some bids also coming from the MNRE side on the green hydrogen also, as has been committed by our Honorable Mr. of Bar that will be coming up shortly with the bids. And when the bids come, we'll have to see of what kind of provisions are there in that to encourage the industry to venture into a thing which is not commercially viable at this very stage. And that is where this issue will come into fore. Second aspect which we are thinking primarily is the low efficiency of this green hydrogen issue. See, the marketability, viability is all linked to this efficiency part as well. As of now, the hydrogen is lying on the lowest ebb of the efficiency with other technologies which we are there. But a lot of R&D is going on. We are expecting that this efficiency segment will also grow up a little more on the viability side. So these are the issues which are worrisome for the industry as on date to fully barge into this field. But of course, since this has a very big potential and it's need of the hour, and India being rich in RE sector, and we are going to fulfill our dreams of 450 gigawatt by 2030, I think it's going to be future of India, the green hydrogen. And Greenco being the largest player, I think we cannot avoid ourselves from it. It will be strongly and in a big way in this in coming years. Thank you.
Okay. Mr. Robert, to you for your opening remarks or comments.
Okay, thank you very much, Khushbu. So I'm going to give you a perspective more from the U.S. and what we've experienced here. We're been in the hydrogen business in the U.S. for over probably 50 years with NASA and industrial hydrogen, and then with the hydrogen energy. And I think one of the things that India has that's an advantage is the cost of renewable power. It's some of the lowest in the world. And the renewable energy availability, which drives the economics for electrolysis as we invest our capital, or as you invest your capital in electrolysis, you want to be able to use the electrolyzers as much as possible. So the amount of renewable energy, or the times of day you can use that electrolyzer in India, is very high. So I think that bodes very well for India in terms of green hydrogen. The other aspect that I would say is critical is how do we use the oxygen, right? Because we have that oxygen availability available with the hydrogen. And so being able to find value for the oxygen through maybe a steel mill application, a glass application, cement plants, that could be a very attractive way to increase the value and improve the economics for the production costs for green hydrogen. And then in terms of the technology, I think one of the speakers had mentioned, I think it was Mr. Panda mentioned PEM versus alkaline. And alkaline, we see alkaline cost going down very fast at scale. And so if there's not the need for dynamic response or quick response, and we can get away with slower response, the alkaline technology becomes more favorable. If you need demand response and grid control, where you have to turn those electrolyzers on and off, then the proton exchange membrane or the PEM stacks become more favorable. those are more expensive today. And then when it comes to storage, I think Mr. Panda mentioned underground storage, and in the U.S. here we have salt caverns and we have formations underground where we can store a lot of hydrogen. We can prepare those salt caverns, and so in Texas we have 30 gigawatts of wind power, and that wind power is in West Texas where there's no market, right? But there's the ability to store that hydrogen from wind in a cavern and then potentially liquefy that. And I think one of the things in the U.S. that makes us a little more mature is our ability and the ability we have had to liquefy hydrogen. So if you're able to store that hydrogen underground, liquefy that hydrogen, be able to transfer that hydrogen or transport that hydrogen from the production facility into the markets via rail, via train. And then if you think about the way LNG is and that supply chain for LNG is today, you could imagine the same type of supply chain for liquid hydrogen, where we can then begin to export hydrogen from those areas like Australia, where there's a lot of renewable energy and renewable resources, to other parts of the world. So we see India being in a nice position from the need for energy, the ability to make low-cost renewable power, and then probably not have to transport that hydrogen as far as many countries like the U.S. where we have to go from one coast to the other. So that's I think where we see India being a very attractive market, and it's really coupling the industrial use of the oxygen with the ability then to produce the hydrogen and get the economic benefits of both products coming off the electrolyzer.
Okay. Mr. Nanda, a question for you: that has Greenco got any technology partnerships or technology tie-ups or joint ventures sort of planned in this space at the moment?
Yeah, it is not appropriate for me to name at this stage, but definitely that part of the process is on.
Okay.
And we will be needing that in the initial phase of our into the system.
Okay. And so what are the 3 top priority areas for Greenco at the moment in this space?
As I said, the first priority is for the storage, and the same priority is for FCVs. We are looking for that as well. So these are the basically 2 priorities where we are planning to venture, because since we have good establishment in the RE sector in the southern areas, so we might look for a sectorization when we venture into that. Because wherever we have those concentration of our solar and wind projects, so we might concentrate on those areas in the initial stage, because the transportability and other issues are also there which are adding cost to that. So we'll try to minimize that in the initial stage to have more commercial viability.
Okay. Mr. Robert, a question for you: that how have you seen the costs and the cost economics evolving, in all your experience and the company's experience, and which technology do you foresee becoming, the most dominant in this space?
Well, I think it's an evolution.
Okay.
So I think Mr. Buckley mentioned blue hydrogen, and one of the things that we see in the United States is we have large SMRs, or steam methane reformers. We have low-cost natural gas, and we have big SMRs that can do, say, 250,000 kilograms per day, so 250 metric tons a day of hydrogen. That if we see the oil and gas or the petroleum industry start to diminish, and that capacity now is stranded, this hydrogen capacity, one could imagine blue hydrogen being that bridge and being able to use those existing assets, which produce hydrogen, gaseous hydrogen at $1.20, $1.50 per kilogram. And so you can imagine with with that scale and putting a carbon capture onto the existing SMR, that's a bridge we think will get you to green hydrogen. And so the cost for green hydrogen will come down at scale as we see these megawatt scale electrolyzers. Mr. Buckley mentioned the Air Liquide facility that just went up in Bécancour, and that's a large scale, but you'll see scale in the hundreds of megawatts. And as you get to those scales, you'll see those numbers come down. And as the technology evolves, the cost of green hydrogen will come down. But I think in that interim, at least here in the US, where we have these big, large-scale SMRs, we're going to need to use those and create that blue hydrogen to get us to the green hydrogen.
Okay, and specifically on electrolyzers, like PEM or alkaline, which is faring better or which is faring worse, and the reasons for it, Mr. Robert, for you only.
I think the alkaline right now is the more mature technology, and it's going to reach that go down in that cost curve quicker than the PEM. But as you see scale with PEM, you see the fuel cell stacks that are actually creating the power. You'll see enough of that material and the scale of that material, the demand for that material should reduce the cost of PEM technology. And I think when it comes to grid management and response time, PEM is going to be the technology to play the role there.
Okay, and Mr. Nanda, for you, which renewable energy source would you say would be more dominantly used for producing green hydrogen in India? Which would you say makes more commercial sense, or which are you considering?
See, in India, I think it's going to be equally between solar and wind. Because solar, already we have seen very low prices on the solar side. So that's a very, very big encouraging factor in the cost effectiveness in India. On the wind side, also we have quite low prices. But I think this will depend a lot on the offshore wind development in India. The moment we have a bigger offshore wind developments, I think that will be a point where the wind cost also we might see a drastic change in the coming times. So that will maybe a few years down the line on that front, because the offshore wind we are just starting to venturing into that side, and then once it physically comes up, then we'll see how competitive the market becomes with that. But as of now, if you look at, I think the solar is at a stage where the takeoff is possible with the solar combination into the green hydrogen. And that, as far as Greenco is concerned, since we have taken our steps towards this flexible RE power and schedulable RE power, I think that's an area where the green hydrogen as a storage also becomes a major component for us to keep into that. So it looks like in India, the scenario is ready for the solar to start with wind joining shortly, I think, in the fray.
Okay, and Mr. Robert, to you, so in the US particularly, which is already which already has a lot of offshore wind capacity coming up, do you see offshore wind becoming sort of a more prominent renewable energy resource for green hydrogen production?
I think eventually it has to, because you run out of land.
All right, and According to you, what are some key lessons that India can adopt from other emerging markets in the world, like US or some European countries like Germany? What, according to you, would be those key lessons?
Okay, so I would say from our experience, one of the main drivers for the adoption of hydrogen energy and fuel cell electric vehicles and zero emission vehicles are the policy drivers. So it's anything from the carbon markets and having carbon markets that function to low carbon fuel standards to these zero emission vehicle mandates like we see in California, Canada, and some of the other states. So those are very good drivers to push the technologies out there. And then we're seeing a lot of what we call voluntary initiatives by corporations like Microsoft, Amazon, and they're doing it just as really as part of their environmental sustainability goals. And then as far as lessons learned, it's really taking down the barriers in terms of understanding and putting in place codes, standards, and regulations that allow for the installation and siting of hydrogen production facilities and then hydrogen refueling facilities, which would be I think probably the biggest challenge here in the United States is getting communities to adopt hydrogen and let hydrogen be in their community, because there's a lot of preconceived ideas and notions about hydrogen and what hydrogen, how safe hydrogen is.
Okay. And Mr. Nanda, for you, what, according to you, are the key prerequisites for developing a green hydrogen economy in the country? Like, if you could, suggest the government some 3 key pointers, then what would those be?
At this stage, there are a lot of points which need government's consideration towards this side. But the key, I think, one is enablers, which government has to come up regarding the. Am I audible?
Yeah, you're audible.
Khushbu, am I audible?
Yes, you're audible.
Hello.
Hello?
Yeah.
Yes, yes, sir, you're audible.
Yeah, am I audible, Khushbu, now?
Yeah, you're audible, sir.
Yeah.
Yeah.
So as of now, I think since we are looking for pilot projects to be taken up at this stage, so what are the policy key enablers government will put in frame regarding the viability, like taxations and other things? That's the one point which is there predominantly at this stage. The second point is, I think the key enabler which government has to look is, as I said earlier, also the electrolyzer development in India. I think that's an area where India can play a bigger role, not only in India, across the world also, because we being a big country, big manufacturing facilities available, if a lot of R&D is done in a proper manner, I think India can be most competitive in the electrolyzer costs in India. That's another area. And third point is adaptability, uh, where we are primarily want to use this green hydrogen initially. Are we giving priority to FCVs in the beginning itself, or we are trying to use hydrogen for the grid management? We personally feel grid management is one issue where the priority should be given at this stage in addition to FCVs. Industries where we want to use green hydrogen later on, steel, refinery, other, I think that can be a little later date, because that I think at this stage might not be the priority. So point is policy, and plus the manufacturing facilities which we want to create on R&D on the electrolyzer side. And third is the priority towards the grid management and FCVs. I think these are the three areas where we need enablers coming from the government side initially to give impetus for the private developers to venture into that.
Okay. Thank you. Now I'll take some questions from the audience, and if time permits, then I'll again move to my questions. The first question that I see is for Mr. Robert from Sudhir Pathak. Mr. Pathak wants to know that in electrolyzers, for higher capacity means adding modular stacks. How does that improve the economics? And what are the components in alkaline and PEM that will be contributing in improvement in efficiency as a way forward?
Well, that question is a little out of my technical capabilities. I can't answer that one. I can tell you that when we look at the MEA for PEM and that substrate, when we get to scale on both the fuel cell and the power generation side and the electrolysis, that should allow for more demand and more cost reductions for that primary material.
Okay. Then I think the next question Mr. Nanda can probably take up. There's a delegate from the Australian government, I believe, who wants to know that would there be companies in India looking to participate in the development of the hydrogen hub with all the government support and required technologies available in other countries? They want to know that they have such opportunity, present in Western Australia. So probably they're asking in that respect.
It's yes and no both at the same time. I would say, it's confidence level which has to come in the industry as of now. If you look at India, I think all major players, Adani, ourselves, and other players, they are strongly looking to get into this hydrogen. So I think the competitiveness. Am I audible, Khushbu? Or the link has gone?
Yeah, you're audible. Mr. Nanda, you're audible. I think if you can stop, if you're facing bandwidth issues, probably stopping your video might help improve the bandwidth a bit. You're muted, sir. I think you're muted. Can you try speaking once again?
Hello.
Yeah, clear now.
Yeah. So what I was saying is that as of now, if we look at the energy rates in India, particularly in case of solar and wind, so these are on the lowest ebb as compared to comparatively to the world. So the opportunity, I think, is ample in India to start with this. So joining in fray in other countries and international hubs can always be an option. We cannot rule it out, but it looks more appropriate to start with India. I personally feel.
Okay. Then, Mr. Robert, there's a question for you that Aditya Suresh wants to know that could you help us scope out the key equipment related companies, including chart involvement across the global hydrogen value chain?
Oh, that's easy. So a little bit about Chart and how we fit into the overall value chain is we partner with companies like a company like McPhee, who is an electrolyzer manufacturer of alkaline-based technology. And we don't produce the molecules, but we want to be able to liquefy. So our business is really around the cryogenics. And so where we fit in is taking that molecule, and this it could be LNG, but this time it's hydrogen. And we, like I said, we see the hydrogen value chain playing a similar role to the LNG value chain. And so when we liquefy that molecule, we can store that molecule in a lot denser form. we can transport that molecule, and we make the trailers to transport the molecules. We make the storage vessels, and then we make the equipment downstream, like the fueling stations, and we make liquid hydrogen pumps. And some of the benefits you get from liquid is the ability to compress a lot of hydrogen in liquid form to gas, lower capital, lower energy, higher volume. And so when you look at scale, which is what we've experienced here in the United States, you're going to need to accommodate that scale and that demand with things like the liquid supply chain. And then you can go downstream to marine, where we see, and we talk about ammonia, or we talk about liquid hydrogen, and that's all going to shake out eventually. And then you can carry that hydrogen overseas to other countries, put that hydrogen in ISOs or ISO containers, and then put that on trucks. So there's that liquid supply chain, which is where Chart really wants to play, is what we see as the future when hydrogen becomes scale, at least for the bulk applications and the transportation. And it really is the virtual pipeline that eventually could become a pipeline in the future, right? And be able to, we could be able to have pipelines like we have for natural gas today that are able to transport hydrogen. Today, we can't use the same pipelines because when you go to 100% hydrogen, you run into problems with hydrogen embrittlement, where the materials might not be compatible. And so Chart sees the world as becoming a liquid supply chain, very similar to what we see with LNG today.
Okay. Another question for you, Mr. Nanda. Mr. Nikhil Matthew wants to know that what are the immediate plans of Greenco in terms of green hydrogen? And yeah, and there's another speaker, there's another delegate who wants to ask you that what is the scope of for the use of hydropower for powering green hydrogen electrolyzers?
The first part, I think, is the same which I replied earlier also, that we are primarily looking into the storage and FCVs, because our endeavor is for the flexible, schedulable, renewable power. So I think the storage is one component where we are looking for it. FCVs is another component which we are looking at it. Hydropower, if you say, is as a technology, if you say, yes, it's a part of it, but primarily on our part, we are not looking exactly for that part of for the hydrogen as of now, as green.
Okay. And Mr. Robert, there's a question from Mr. Nikhil Matthew, who wants to know what is the scalability of cryo-compressed storage in seasonal storage?
So cryo-compressed, I guess they're talking about not liquid storage, but liquid storage at pressure or cryo-compressed. What we see the benefits of cryo-compressed being is the ability then to make that hydrogen a little more dense than the liquid hydrogen itself, and then the ability to not have the boil off that we would typically have. As far as size of vessels, we see the technology right now being more of an onboard storage technology for heavy duty vehicles, and maybe not having to go upstream of that, at least for the time being, right? I think the place to have the cryo-compressed is in the onboard storage of heavy duty vehicles, where you need the density and you need the payload for the range.
Okay. I see a lot of questions on my screen, but I probably just have time for two more short questions. First is, any of the speakers can take this up. Is there any possibility of adopting hydrogen-based IC technology, or is it too far-fetched? By IC, I think he means internal combustion.
I think too early to comment on that because we are talking about FCVs at this stage. Let's get on to FCV, and then we have that entire supply chain established across the country regarding filling stations, transportability, and other things. I think that will be the first stage where everybody across the world is thinking about as of now. But as a concept, yeah, maybe future R&D give us some idea about it.
Okay. Mr. Robert, there's a question for you from Mr. Akhilesh Bhandari. He wants to know that even with thermally insulated containers, liquid hydrogen tends to boil off and leak away, typically at a rate of 1% per day. How do you see that challenge being overcome?
Yeah, I think that boil off rate is dependent on the size of the vessel. So for our large vessels, say 60,000, 120,000 gallon vessels, that boil off gets is down at about 0.5%. And there's ways to use that gas, either to take that off gas and power a fuel cell and generate power. That's one alternative, and then sell that energy back or put that energy onto the grid. So that would be for a stationary application. And then there's ways to basically take that boil off, compress that, and put it into storage, as long as you have a downstream use and you can eventually empty that or consume that gas. So there's ways today so that we handle boil off and be able to use that boil off without letting it go to waste.
Okay. And just before we close this session, quick word from both of our speakers, first from you, Mr. Nanda, and then from you, Mr. Robert. Your outlook for green hydrogen, scaling up and commercialization in India, and for you, Mr. Robert, if you can shed light on India, then that works. Otherwise, in the US. Mr. Nanda, to you first.
I think we can see pilot projects coming shortly in India. Maybe by another 2025, we will have some pilot projects in place because NTPC is trying hard for it and they are working quite keenly on this. As far as Greenco is concerned, I think we might also have our pilot projects in place in next 2 years on the hydrogen side. So, but the scalability, I think, is which we see somewhere around reaching 2030 level, in between that part only, because the electrolyzers and other things, because we are looking at a bigger scale, we are not looking at a smaller scale. So the electrolyzers, the kind of development which are going on, we might have 100 megawatt electrolyzers available by 2025 or so. So I think the scalability will happen somewhere around 2030 only. Before that, we don't see a huge scope of scalability going up on the grid levels in this case.
Okay. Mr. Robert, your thoughts on this?
Yeah, I think near term, if India could find a nice demo scale project where, again, we use the oxygen in an industrial setting, because you get a lot of oxygen weight-wise for a cubic foot of hydrogen, and then that hydrogen can be used in the pipeline or the natural and feeding a power plant. It can be used for powering vehicles. You can take the hydrogen where you need it, but you can use that oxygen. And then once you use that oxygen, if you apply that oxygen to processes like maybe a glass melter or a steel mill, where oxy-fuel combustion comes into play, then you have a more concentrated stream of CO2, where you then can capture that CO2, which you have to use that oxygen in the process to make the material. And then you have the best of both worlds, right? You can have an oxygen molecule going to a process that's then going to be green, and then have your green hydrogen molecule that can go to any application that makes sense based on the priorities for India.
Okay. Thank you so much. Thank you to both our speakers for an excellent discussion. I think our delegates are also very happy that we've managed to pretty well take up a lot of these questions. And please feel free to stick with us throughout the end. We have more such interesting discussions lined up. And with this, we now move to our next session.